Yes, the recording is started. You can write your roll numbers in the chat box. Right. I hope this is visible. Sorry. Let me share the screen first. Is it visible? Hello. Hello. Can someone respond? Hello. Hello.
Yes, sir.
Okay. Right. So let us quickly discuss, or let us quickly understand the things which we have discussed in BLE and ZigBee, and then we will proceed for the next point of our discussion is Wi-Fi. Right. So BLE, these two communication technologies we have discussed so far. One is BLE, Bluetooth Low Energy, and second one is ZigBee. Okay. So both technologies are standardized by IEEE. Hence, very first comparative point we have written here as IEEE standard. So first BLE is 802.15.1. Right, so 802.15.1, and IEEE standard of ZigBee is 802.15.4. Then data rate supported by BLE is 300 kbps, and that of ZigBee is 250 kbps. So if we require higher data rate, we should prefer BLE. But when the range is higher range is required, then in that case we should prefer ZigBee, because the range of BLE is 10 to 15 meters, and ZigBee with a ZigBee you can communicate to the devices up to 100 meter, right? So that is why if higher range, long range communication, if we are using uh, for long range communication, we can use ZigBee module. Then topology used for BLE, it's star topology, right? So direct connection with the central coordinator can be possible. Means master device can communicate to each and every slave device directly. But in ZigBee we have one more option, that is mesh topology, right? Star as well as mesh topology. Modulation technique used in BLE is Gaussian frequency shift keying, and modulation techniques that are used in ZigBee are binary phase shift keying, amplitude shift keying and quadrature phase shift keying. Right. After that, operating frequency, this BLE operates at 2.4 gigahertz, which is basically ISM band, industry, this scientific and medical application band. Right. So ISM band basically do not require licenses, and you can use ISM band for communication. So this is BLE that make use of this band. And in Zigbee, you have three options, but first two are not used in India. In India, again 2.4 gigahertz, 686 megahertz, 915 megahertz, and 2.4 gigahertz. We can use 2.4 gigahertz. Right, so BLE and Zigbee both are at 2.4 gigahertz. Then we have latency. Since star topology is used, low latency in a BLE, high latency in a Zigbee. Then cost, if you compare both the technologies, were they are low cost solutions for wireless technology. Then power consumption, we know both the devices, means BLE device and Zigbee device, they spend most of the time in the sleep mode, power saving mode. So both of them, they consume very less amount of power. Right. So this comparison we have done. Then we have moved on to the next communication technology, which is Wi-Fi. Right. So I told you Wi-Fi. It was it was invented in 1997, and initial speed that it used to give is 2 mbps, 1 to 2 mbps. And I told you how this 1 to 2 mbps goes on divided if the number of users gets increased, right? So it's very hard to get 2 mbps speed at actual if number of users in that wireless network are more. Right. So it is a short form of wireless fidelity, and this Wi-Fi is a wireless technology that use radio frequency to transmit data through air. Wi-Fi is based on IEEE standard. Here I have mentioned some of the classes like 802.11a, 802.11b, 802.11g. Right. So first two was invented in 1999, and after that some enhancement is done in the available classes. And in 2003, we got this 802.11g. Right. So Wi-Fi is initially introduced by Wi-Fi Alliance. This Wi-Fi Alliance is a non-profit standard organization, and it is also called as Wireless Ethernet Compatibility Alliance. Right. Followed by some of the benefits we have discussed. What are the advantages which make this Wi-Fi very useful, which make this Wi-Fi popular? Right. So these are the few benefits or advantages of using Wi-Fi. So first one is wireless Ethernet. We know that if I want to use the internet, then I have to use the Ethernet, right? So it's this Wi-Fi is an wireless replacement to the Ethernet. That is what I said. We can consider this. It simply replace the wires which are used to have. They simply replace the wires which are required during network connectivity, right? So Wi-Fi is nothing but wireless Ethernet. Then second benefit in that is extended access. Right. So extended access means the in the absence of wired in the absence of wires or cables, extended access to the places where wires and cables cannot go, or where it is expensive to go. Right. So extended access simply means one of the example I told you yesterday. Suppose you are having some peak and valley points. In that case, you cannot take the wires throughout the communication range. You simply have to uh, give the Wi-Fi access, right? So if I could draw this with the paint, the scenario would be a very simple one. Why I'm saying it is extended access, that I'll tell you. Right, so I hope this is visible. Right, suppose you are having a station at this point. This is a transmitter, right? And let's say you are having a receiver at this end, but in between you are having a valley point, right? And suppose you want to transmit a data from this end to this end. In that case, if you are dealing with a wired connection, then you have to take the wire from this point through the ground or on the ground to station B, right? So this is station A and this is station B, and the data can be transmitted from A to B through wire in this way. Rather, what you can do is you can go for Wi-Fi, in which this wireless access to this from station A to B is provided, which is very cost effective. That is why we can say that it is extended access, right? Even through wire, it is not possible to go from A to B. Still, this Wi-Fi gives the access, right? So that's why it is said like extended access. Then we have cost reduction, right? So cost reduction means here, in the absence of wires and cables, we can easily bring the cost of the cables and all that down, right? So this is another thing. Just a minute. Yes. Next, this one is cost reduction. I think cost reduction I have discussed. Then next one is mobility, right? So mobility means wires that ties you down to the one location, but with a wi-fi connection you can move here and there without losing your connection, so you have liberty to change your location. And last one is flexibility create opportunity to new devices to get connected with the wi-fi. This is what the flexibility is. So with those benefits we can move on basic components of wi-fi. So let us understand what things are involved in a wi-fi, right? So all these wi-fi network they can join wi-fi network, all the devices that can join the wi-fi network, whether it could be a mobile, then it could be a portable device, or let's say fixed, or let's say wireless stations. They are the components of wi-fi, right? So all those stations who are in the network, all those physical devices are called as the components or basic components of wi-fi, right? So there are some stations, we will call those devices which are in the wireless network, we will call them as a wireless stations, right? And it is abbreviated as sta. So let me write here, first component in that is STA. This is the first component. Then we have, let's say, for a wireless station, it may be PC, laptop, mobile, PDA, right? So wireless station can be a PC, it can be a laptop, it can be a mobile or PDA, right? So when two or more stations, two or more STAs, if they are connected with each other, so they will form a BSS. BSS stands for basic service set. They are connected means they are forming a basic network, a small network, right? That's why they are called as a BSS. On the in the figure you can observe this BSS, basic service set, in which you can find one STA and a second STA. They are communicating with each other, right? So basic component of Wi-Fi are wireless stations, that is STA, and second one is BSS, right? And one more component which is required here to coordinate the communication, right? So this BSS is a set of STAs controlled by a single coordination function. We will call it as a CF. It is a single coordination or coordinator function. This CF is logical actually, right? So among one of the STA is referred as CF, which will coordinate the communication, which will coordinate the function, right? Usually we call such a coordinator function as AP. In this diagram you can observe here AP, right? So this AP is nothing but access point, but in this case it is operating as coordinator function, right? So basic components of Wi-Fi, it includes three parts. One is STA, wireless station. Second one is BSS, it stands for basic service set. And third one is CF. CF stands for coordinate function, right? So these are the basic components of Wi-Fi. Now next is operating modes. Now let us understand what are different operating modes. There are two operating modes in Wi-Fi. There we have two operating modes in Wi-Fi. In that, first one is ad hoc mode and second one is infrastructure mode. Yeah. So the operating mode is selected during configuration of Wi-Fi itself. The operating mode is selected during it is decided during configuration of that network. All the wireless devices, all the wireless stations must select an operating mode before they attempt to create or join a wireless network, right? So before joining the Wi-Fi network, you should decide whether you want to behave as a wireless station or coordinate function. Means what? Before getting into the communication, you are deciding whether you want to behave as a slave or whether you want to behave as a master, right? This is as simple as that. So you decide your role before getting into the wireless network. You means your mobile or your PC or your laptop. Before you get into the wireless network, your device has decided to go in a slave mode or a master mode, right? So let us discuss about ad hoc mode, right? So ad hoc mode is a temporary, it's a kind of temporary network which is created on demand, right? Suppose two devices are there which do not require the internet connectivity, but these two want to exchange the data among themselves. In that case, you can establish the ad hoc mode network, right? Very nice example I can give you here is a data transfer through your share it. I hope all of you might have used that app, share it. So in case of data transfer, in case of transfer of huge media files, you can use the share it, right? So share it will establish the ad hoc kind of network which do not use internet, right? So with the help of share it, you can establish a small network which is temporary network, and after transmission of complete data, you can stop or you can close that network, right? So share it is one of the good example of ad hoc network. So wireless stations communicate directly with one another using ad hoc mode. They communicate with each other directly, right? So this is what the ad hoc mode is. Then next one is infrastructure mode. In infrastructure mode, the operating mode requires one access point, right? So you can observe this infrastructure mode over here. A distribution system is shown here, and all the basic service sets are connected with that distributed system, right? So the infrastructure operating mode requires one wireless access point, and that access point is a station. It will be basically a wireless station with additional functionality, like a major role that access point play is that access point play is extended access, right? And to the wireless network for this client, wireless network actually use it makes use of access point, and access point further coordinate the communication, right? So access point is required in every infrastructure mode Wi-Fi. So the similar infrastructure mode Wi-Fi you can see in our college premise, right? So uh, the distribution system is our central NCAN facility, right? So NCAN facility is almost 1 Gbps lease line. So that 1 Gbps lease line is nothing but our distributed system, and different access points are configured with the help of switches and routers. They are connected with that NKN 1 Gbps lease line. All those access points which are placed at different locations of the department, they are connected with that central lease line, right? So here you can observe this distributed system which is connected to AP. AP stands for access point. It would have a small unit that contains a kind of let's say antenna which would be able to radiate means transmit and receive the signals, right? And along with that, you can have different number of stations, wireless stations, which can get the services from that AP, which can get the services broadcasted by that access point. right? This is how the communication with uh, infrastructure mode happens. All the wireless devices trying to join such a bss must provide or must be associated with the ap. Suppose I want to get access to the internet, I must get connected with the access point, right? So nearest access point will provide me the different services that are provided by distributed system. And this access point provides access to its associated sta to ds. So what is the role of access point here? Access point provides different services that are coming from distributed system to the wireless stations which are connected with that ap. This ap will provide the services to wireless stations that are coming from distributed system. So this is the role of access point, right? So I hope basic components and operating modes are now clear. If you have any doubt, you can ask. Any doubt? If you have any doubt, you can ask. Otherwise, we can proceed further. At least someone say no doubt, sir. Otherwise, we have to wait.
No doubt, sir.
Okay. Now, next and a very important part, I told you in the same sequence we will study all the communication technology, the sequence which we have followed for BLE and ZigBee. In the same way, we will learn this Wi-Fi as well. Here, I have shown you the five-layer TCP/IP, five-layer TCP module. This is five-layer TCP protocol stack. Very similar to that, this 802.11 and its extensions are like A, B, and G. They define two layers in the five layer, right? So TCP model have this physical layer and data link layer, right? So basically those two layers, physical layer and data link layer, are important, and which are described here, which are going to be served for different purposes. I'm not going to talk about network layer because what are the functionalities associated with a network, transport, and application. You might have seen this TCP layered architecture. So in that you have seen this network, transport, and application. I will be focusing on physical layer and mac layer, that is your data link layer, right? So let us understand that those things one by one. But the data link layer is made up of two sublayers. So if you observe this data link layer, it is having two sublayers. One is called as mac, medium access control, and second one is DLL. DLL stands for data link layer, right? So let us understand the functionalities associated with the physical layer first. This PHY, that is physical layer, performs some tasks such as modulation of the signals. So if I would like to talk about modulation, can someone tell me what is modulation? What is modulation? What is modulation? Okay, good. Good response actually.
Imposing low level signal on high signal.
Okay, good. So let me tell you what is modulation. Modulation means basically strengthening the signal. Suppose you are having information. Yes. So, information signals, suppose you want to transmit from one place to another place. If they are weak, it is very difficult to transmit those weak signal from one place to another place. So, we have to strengthen those signals in terms of amplitude, in terms of phase, in terms of frequency, all that. Right? So, different techniques are there. So, modulation means simply a strengthening of information signal. More precisely, I can say that strengthening of information signal with the help of carrier signals. Right? So, carrier signals are added and varied according to the information signal, so that the information signal can travel at a longer distances. This is what modulation means. Then we have encoding. So, encoding is another task that is performed by physical layer. Now, can someone tell me what is encoding? If you know, encoding is a task that is performed by physical layer. Now, can someone tell me encoding? What do you mean by encoding? What do you mean by encoding and decoding? Okay.
Converting data from one form to another form.
Okay, converting data one form to another form. Okay, good, very nice. Just to describe this, let me add one slide.
Adding some extra bits.
Correct, adding some extra bits, or you can say adding some parity bits into the existing sequence to hide the original sequence. Right.
Yes,
So,
sir.
let me say, suppose you are having a data like 110. Right. So, suppose you are trying to transmit this data 110. So, if you are transmitting this from one place to another place, and in between during the media, uh, if somebody is able to catch the signal, the data will be easily trapped. It will be stolen, right? So the data is not simple as you think, but most of the time it could be a password. When you hit some password, if you talk about the ATM as an example, when you hit the password, it goes to the internet, it goes to the cloud, it goes to the server where all those security keys are stored, which are associated with the login credentials. If you hit this key after putting the ATM card into the machine, all the information, if it is trapped, it can be stolen. So the security information related with the banking sector is very, very important, and security aspects are required to be taken care, right? So instead of sending this 110, suppose I hit this as a password, let's say 4 digit, right? So the password, it could be let's say a precise message. Usually I can give with a very nice example, just to say that let's say people send very secret message like 143, right? Imagine the situation. Suppose it has been seen by let's say parents. What will happen, right? So imagine the situation. Suppose person A want to send a message to person B. I'm just trying to tell this in a very interesting manner, right? So person A want to send a message 143 to person B. This is a short message service. SMS is to be sent. But actually, if the person, if the family member of person B, if they observe, if they see this message, what will happen? Imagine the situation. That's why person A is very smart enough to encode the signal. Encode the signal means what I will be doing is, let me add some parity into it. Let me write this as 1, this as 0. Then I could add, let's say, 5. Then I could add, let's say, 7. Then I could add, let's say, 9, right? And after that, if I say even places are parity bits, right? This is my encoding algorithm. Even places are parity bits. What is meaning of that? All the even places in the given sequence, they are parity bits, right? So what exactly happened here? I just have this thing encoded. I have encoded the message which requires some security, right? So this sequence is encoded. So at the decoding end, how you can proceed to decode that? How to decode? How to decode? You have this algorithm which is shared with the receiver, right? And every even place which is a parity bit, I can take it here. Every place which is a parity bit, I will mark it as red, let's say. All the even places are marked as red. And we know that they are parity bits. They are just a garbage values. They are just added in the message to hide the contents, right? We know that these are the garbage values. So I can remove those places. I can remove the data from that. And finally I can just get it converted into original message 143, like that. Right, so this is what encoding is, means hiding the sequence by adding some parity bits, by adding some garbage values into it. I hope you understood this. Encoding and decoding. So at the receiver, decoding happens. At the at the transmitter, the things are encoded, right? Provided that the algorithm has to be shared by transmitter and receiver. With that, let us move to the protocol stack. Right, so encoding and decoding, I hope is clear. Then we have another functionality associated with physical layer, associated with this physical layer PHY. The functionality is bit by bit transmission. So bit by bit transmission and converting that into the electromagnetic spectrum is the role that has to be played by physical layer. And it should operate in ISM band, and we know that ISM band is at 2.4 gigahertz. So this Wi-Fi also make use of 2.4 gigahertz frequency for its transmission. Next one is MAC. Next one in that data link layer is MAC, right? So MAC is one of the component of data link layer. Now let us understand what are the roles played by MAC, that is medium access control, media access control. So the functionalities associated with this MAC are sublayer. It is sublayer of DLL. It control transmission of data. This is first functionality. Second is mobility management is the task to be performed by MAC. And third one is it uses CSMA CA. MAC uses CSMA CA. CSMA CA stands for, can someone tell me CSMA CA? I hope you have studied this CSMA CA in computer network. right? This is collision avoidance protocol that has been used by Mac then while doing this Mac framing, right? So Mac framing we will discuss. Mac framing is like this. This is a Mac frame, right? Which consists of 5 different things. This is Mac frame, which consists of 5 different fields. In that, first one is BS SID. This one is BS SID. Then we have DA. Then we have SA. Then we have RA and TA. So long form, they are abbreviations of, let's say, BSSID stands for, it is a short form of BSS identifier, basic service set identifier. Then we have destination address. Then we have source address, initial source address. Then we have receiver address, and then we have transmitter address. See, most of the time we have multiple access points. Means what? The data is being transmitted from one place to another place, right? Source address and destination address is final. Source address and destination address means just to give you the brief idea. Let me open the thing once again. Suppose you are having a network with a different number of different number of stations. So let's say this is a distributed line, and first AP is connected here. This is your first access point, and you may have another access point somewhere here connected, right? You may have another access point somewhere connected here. And suppose you are having a mobile device which is connected here. This is your mobile device which is getting a services from this device, this access point, right? Suppose I want to access the internet. That means the services will come from this access point to this access point first. Then the services will go to the next access point, and then from this access point to a mobile node, the services will come. So who will be the source? This is the source, and this is the destination, right? In between, the roles of those access points goes on changing. That means for the next transition phase, this will act as a transmitter, and this will act as a receiver, right? So this access point will act as a receiver for first transmission. After that, this access point will act as a transmitter, and this will act as a receiver. Then after that, this access point will act as a transmitter, this will act as a receiver. So source and destination will remain same, but transmitter and receiver keeps on changing, and hence the MAC frame keeps on changing. So destination address is appended here, source address is appended here, but this receiver address and transmitter address keeps on changing, and that depends upon the link during which the communication is happening, during which the packet or during which the frame is going to be sent, right? So this is what MAC frame means. Here source address and destination address will remain same. Receiver address and transmitter address keeps on changing. Whenever you change the access point, whenever we change the link, this receiver address and transmitter address, this field will keep on changing. I hope it is clear. I hope this MAC frame you understood. After this, those 5 fields, you can have the data. You can have the payload followed by those 5 different fields, which are shown, which is not shown here, but here you can have this payload added here with this MAC frame, right? So next point here is the characteristic. I hope you have understood the things which are discussed so far. If you have any doubt, you can ask me. because next part, which is actually a characteristic which will require more time to discuss, so better we will go for the we will do that in the next lecture. So I give you the time to discuss the things. If you have any doubt, you can ask, you can discuss. Silence means I can treat this as a no doubt situation. Right. So if you have any doubt, you can ask me any point of time. Second thing I would like to tell you here about the ISC. Right. So very soon there would be the ISC schedule. In that, the syllabus for ISC, first ISC, it would be Unit 1, Unit 2, and Unit 4. Unit 1, Unit 2, and Unit 4. This would be the syllabus for ISC first, right? So it will not be like first section, because we have not completed third unit. It will take huge time to complete Unit 3. So instead of Unit 3, we will consider Unit 4 for the ISC 1, right? By the time Unit 4 will get completed, after completion of this Unit 4, we will discuss the MCQs as well related with the Unit 4. I hope MCQs of Unit 1 and Unit 2, I think we have discussed. So I will share the MCQs with you, solved MCQs with you for Unit 1, Unit 2, and Unit 4. And based on that, we will have ISC. I don't know exact pattern what has been suggested, but as per as last ISC that has been conducted, we have set the question papers, and students were expected to write the answer, and finally they have to create the PDF file, and we usually give the link to upload that PDF file. So on that link, student can upload the answer sheets of ISC, right? So we will create a link for ISC on which you will find the question paper. So after getting it downloaded, after getting this ISC question paper downloaded, you can refer that question paper. You can have some blank pages, or you can have a notebook which can be preserved afterwards for the record. That notebook, in that notebook, you can write the answers, ISC question answers, and after that you can create the PDF file of that by scanning or by taking snapshots. You can create the PDF file, single PDF file of your answer sheets, and later on we will provide the link to upload that answer sheet. That link can be utilized for uploading the ISC answer sheet, and after that we will have the access. We can check your answers virtually, and we can give you the marks. I hope the process is clear. I hope it is clear how it can be done. If any changes, I will let you know about that. Right. So we will stop here. One session is organized for you guys regarding this skincare. I think it's at 11 o'clock. So everyone will join that session. If you have any doubt, you can ask. Otherwise, you are allowed to leave the session now.